Hello again, my dear students of first secondary. Our lesson today is a second lesson in geometry. Today we are going to talk about similarity of two triangles. First case. Let's go. Similarity of triangles, cases of similarity of triangle. First case, postulate. AA similarity postulate. This is the first case of similarity. We say that two triangles are similar to each other if two angles of one triangle are congruent to their corresponding angles of another triangle. So the first case of similarity is if two angles of one triangle equals are congruent to, we means by are congruent to that they are equal in measure to each other, their corresponding angles of another triangle, then the two triangles are similar. Okay? Here we have two triangles, ABC and XYZ. If measure of angle A equals measure of angle X and the measure of angle B equals measure of angle Y, so of course measure of angle C will be equals to measure of angle Z. So the two triangles are similar. Here you need to prove that only two angles are equals to each other. So if measure of angle A equals measure of angle X, measure of angle B equals measure of angle Y, then we say that triangle ABC is similar to triangle XYZ. Okay? Okay. Remarks. The two right angle triangle are similar. If we have two right angled triangle, so the first angle here is equals to the measure of the second angle in the first triangle, because in the first triangle this is a right angle triangle, so we know that measure of one of its angle equal 90, and the other triangle is a right angle triangle, so we know that he has an angle of measure 90. So we need another acute angle is equal to the corresponding acute angle in the other triangle. So here the remark says that the two right angled triangles are similar if the measure of an acute angle in one of them is equal to the measure of an acute angle in the other. Because we know that here in the first triangle we have a right angle and in the second triangle we have a right angle. The two isosceles triangles are similar if the measure of an angle in one of them equal the measure of the corresponding angle in the other. Here we have two isosceles triangles, so we know that two angles here equals two angle here in the other triangle. So if we find an acute angle equal to an acute angle in the other triangle, then the two triangles will be similar to each other. Here a very easy one, an equilateral triangle are similar, of course, because all the angles of the equilateral triangles will be 60 degree and all the angles in the second equilateral triangle also will be 60 degree. Corollary 1. If a line is drawn parallel to one side of a triangle and intersects the other two sides or the lines containing them, then the resulting triangle is similar to the original triangle. Okay, let's understand this corollary together. Here in figure 1, you can see that ED, the line segment or the straight line ED, is parallel to BC. Since ED is parallel to BC, so we can find that measure of angle D will be equals to measure of angle B, corresponding angles, and measure of angle E will be equals to measure of angle C, corresponding angles. And also we know that angle A is a common angle. Angle A is a common angle in both triangles. So we can write that triangle AED similar to the triangle ACB. Okay? Again, Here you can see that BC is parallel to ED. So whenever you see two parallel sides, BC parallel to ED, so you can write directly that triangle ACB is similar to triangle AED, because we all know that A here, angle A again is a common angle. Measure of angle B equals measure of angle D, two corresponding angles. Measure of angle C will be equals to measure of angle E, corresponding angles. Here in the first two cases we will write triangle ABC. In the first case here we will write triangle ACB similar. Here in the second case triangle ACB will be similar to triangle AED. Okay, here there is a little different between the first two cases and the last one. Here measure of angle E will be equals to measure of angle C, alternate angles, and measure of angle D will be equals to measure of angle B, alternate angles, and measure of angle A here equals to measure of angle A in the other triangle, vertically opposite angle. So we can write here triangle. You have to be careful when you write the vertex of the triangle. Here we have triangle AED similar to triangle. A is a vertically opposite angle, so angle A corresponds angle A, and angle E in the first triangle corresponds angle C in the other triangle, and angle D in the first triangle is equals corresponds angle B in the other triangle. Okay? Okay. So here if DE parallel to BC and intersects, if DE parallel to BC and intersect AB and AC at DE respectively, then triangle ABC, the large one, will be similar to triangle ADE. This is the first case, okay? And the second case, triangle ACB will be similar to triangle AED, and in the last one, triangle AED will be similar to triangle ACB. Okay? Okay, let's go to example 1. In the opposite figure, here DE parallel to BC, AD equals 33, DB equals 22 centimeter, DE equals 2x minus 3, and BC equals 3x plus 1 centimeter. Prove that triangle ADE similar to triangle ABC, and we want to find also the value of x. Here you will write that to prove that triangle ADE similar to triangle ABC, all you have to write that since ED parallel to BC, therefore triangle ADE is similar to triangle ABC, and that's it. Okay? Why the two triangles are similar? Because ED parallel to BC. Okay? Here he wants to find the value of x, so we will solve together. How can we find the value of x? Okay, the two triangles are similar, so the corresponding sides are proportional. Don't say equal, the corresponding sides are proportional. Let's write it together. The first two letters AD over AB, this is equals to DE over BC, and this is equals to AE over AC. Okay, let's write the length of each one. AD equals 33 and AB equals 33 plus 22, which is equals to 55, and this is equals to DE. We don't know the length of DE, so ED is unknown, 2x minus 3. And DC, we don't have DC here. Let's write it again, DE over BC. So this is BC, okay? This is BC. Okay, BC equals to 3x plus 1. Okay, here he wants to find the value of x, and this is the scale factor of similarity, which is equal to 33 over 55. Put it in the simplest form. Divided 11 will be equals to 3. Divided 11 will be equals to 5. Cross multiplication, so we will write 5 multiplied by 2x minus 3 will be equals to 3 multiplied by 3x plus 1. Distribute 10x minus 15 equals 9x plus 3. 9x will go to the other side, so it will be 10x minus 9x is equals to x. And negative 15 will go to the other side, it will be equals 15. 15 plus 3 is equals to 18, which is the value of x. So now x equals 18. Okay, let's solve it again by using the PowerPoint. Okay, here, okay, so we solve it together, and let's go to another example. Exercise. In each of the following figure, prove that triangle ABC similar to triangle ADE, then find the value of x. Okay, let's solve it together. Since ED, again, one more time, since ED parallel to BC, okay, therefore triangle AED will be similar to triangle ACB. Okay, measure of angle A equals measure of angle A, common angle. Measure of angle E equal measure of angle C, corresponding angles, and measure of angle D equals measure of angle B. And we will not write it. We all know from corollary 1 that if ED parallel to BC, then triangle AED similar to triangle ACB. Okay, then we are going to write the corresponding side. So AE over AC equals ED over BC equals AD over AB. Okay, let's write the length of each one. AE, we don't know its length, and also AC, we don't know its length, so we will cancel this ratio. ED equals 4x minus 5 over BC, which is equals to x plus 5. This is equals to AD, AD equals 4 over AB, AB equals 4 plus 2, which is equals to 6. Let's put it in the simplest form. Divided 2 equals 2, divided 2 equals 3. Cross multiplication. 3 times 4x, which is equals to 12x. 3 multiplied by negative 5, which is equals to negative 15. This equals to 2 times x equals 2x, and 2 plus 5, which is equals to 10. Here 2x will go to the other side, so it will be 12x minus 2x, which is equals to 10x, equals 15 will go to the other side, so it will be 15 plus 10, which is equals to 25, and from here x equals 2.5. X equals 2.5. Okay, let's go to example number 2. Okay, in each of the following figure, again, prove that triangle ABC similar to triangle ADE. Here we will write, since DE parallel to BC, so therefore triangle, we will write the first one, ABC similar to, here measure of angle A will be equals to measure of angle A, vertically opposite angle. So we will write A corresponds A, vertically opposite angle. And measure of angle B will be equals to measure of angle D, alternate. And measure of angle C here will be equals to measure of angle E, to alternate angles. Write the corresponding sides. Therefore, AB, we all know that AB equals 2x plus 3. So we write 2x plus 3 over AD, which is equals to x plus 4. This is equals to, okay, BC 5 over DE, which is equals to 3. Here we have a complete ratio. Here we have a completed ratio. So we want to find the value of x. So cross multiplication. 5 multiplied x plus 4. 5 multiplied x will be equals 5x. 5 multiplied by 4 equals 20. This equals to 3 multiplied by x equals 6x. 3 times 3, which is equals to 9. Here 5x will go to the other side. So it will be 6x minus 5x, which is equals to x. 9 will go to the other side. So x will be 20 minus 9, which is equals to 11. So the value of x is 11. The value of x will be 11. Okay? Very easy and very simple. Let's go to another example. Here in this example, measure of angle AHD, measure of angle AHD equals to measure of angle C. This is measure of angle C. So measure of angle AHD equals measure of angle C. Okay? And we have the lenses of AH. We have the lenses of AH equals 14, HD equals 12, BC equals 15, DB equals 4 centimeter. Here it is not given to you that BC is parallel to HD. So here you have to focus that BC is not parallel to HD. It is not given in the problem. So we can't use this corollary in this problem. Okay? But here in triangle AHD and in triangle ACB, you can find that angle A here is a common angle, because angle A is one of the angles of triangle HAD, and it is also one of the angles of triangle CAB. Okay? So here, since measure of angle H equals measure of angle C, given angle A is a common angle in the two triangles, therefore triangle, let's write the corresponding angles in front of each other. So triangle CAB, angle C corresponds angle H, angle A corresponds angle A, two common angle. Therefore the third angle, which is equals to B, will be equals to measure of angle D. So measure of angle B here, angle B will equals to measure of angle B will equals to measure of angle D. Okay? So let's write the corresponding sides. CA over HA, CA over HA, CA its length equal 15, CA its length equal, we don't know its length, so we'll write AC over AD 14 centimeter. Again AC, let's write it together first because I want you to see the corresponding sides or the proportional sides. CA over HA will be equals to AB here, AB over AD, and this is equals to CB over AD. Okay? Here AC unknown side, so we write AC over HA. HA here equals 14 centimeter. AB, we don't know its length, AB is unknown, and AD here also is unknown. Okay, this equals to CB equals 15 over AD D, which is equals to 12. Here 15 over 12, we will write it in the simplest form, so it will be equals to 5 over 4. Okay, now we can find the length of AC, very simple, by cross multiplication. So AC will be equals 5 multiplied by 14 over, okay, here by you can say that AC equals 15 multiplied by 14 over 12, or you can say that AC equals 5 multiplied by 14 over 4. So both of them are correct. You will find that AC equals 17.5. Okay, here one of the important tricks in this example, here he wants to find the length of, here he wants to find the length of AD. Okay, here we know that AB and AD, both of them are unknown. We all know that AB, its length is unknown, and AD is also unknown, and here he wants to find the length of AB. So how can we find the length of AB? Okay, here we know that AC now equals 17.5 and HA equals 14. AB we don't know its length, and AD also we don't know its length. Okay, so I will let that the length of AD equals X. I will let that AD, its length will be equals X. Okay, so if I want to write AB over AD, AB will be X plus 4, because AB equals AD plus DB. So we can write AB as X plus 4, okay, over AD. AD, its length equals X, equals CB over AD, which is equals to 15 over 12, and in the simplest form it will be 5 over 4. So cross multiplication, 4 times X will be 4X, 4 multiplied by 4 equals to 16, 5 multiplied by X it will be 5X. 4X will go to the other side, so X it will be equals to 16. So X will be 16. Okay, so now we know that AD will be equals to 16. Okay, then AB will be equals to 16 plus 4, which was equals to 20 centimeter. Okay, this is a very good example. Okay, you need to solve it again by yourself. Okay, corollary number 2. In any right angle triangle, the altitude to the hypotenuse separates the triangle into two triangles which are similar to each other and to the original triangle. Okay, this is one of the important corollary. I will give you a hint and we are going to complete their problem next time, inshallah. In each of the following figure, find the numerical values of X. Okay, first I'm going to explain the corollary for you. In any right angle triangle, here ABC is a right angle triangle. ABC is a right angle triangle. The altitude means the hypotenuse. The altitude means the height to the hypotenuse. So where is the height to the hypotenuse? The height to the hypotenuse, which is BD. So the altitude or the height to the hypotenuse separates the triangle, separates the large triangle into two triangles. Where are the two triangles? The two triangles are CBD and ADB. This is triangle number 1 and this is triangle number 2. And the two triangles are similar to each other. So the two triangles are similar to each other and each one of them is similar to the large triangle. Okay? So triangle CDB will be similar to the large triangle, and the triangle ADB will be similar to the large triangle. Okay? And the two triangles are similar to the large triangle, which is ABC. Here, this theorem is known as Euclidean theorem, and we have studied in second prep. Okay? So we are going to revise Euclidean theorem, and we are going to solve the two examples together. But first, you need to memorize Euclidean theorem first. Okay? Here, if you want to find AB, here AB squared equals AD multiplied by AC. So here, if we want to find AB, okay, AB will be equals to AD multiplied by the hypotenuse AC. So AB equals AD multiplied by the hypotenuse AC. And if you want to find the other side of the right angle triangle, which is BC, so BC square is equals to CD multiplied by CA. CD multiplied by CE. So AB equals AD multiplied by AC, and if you want to find BC, so BC will be equals to CD multiplied by CA. Okay? And to find BD, you have two ways. To find BD power of 2, you will multiply AD multiplied by AC. Okay? And another way, if you want to find BD without square, here this is BD square. But if you want to find BD directly, you will multiply AB, the two sides of the right angle, AB multiplied by BC over the hypotenuse AC. Okay? Which one you are going to use, which rule you are going to use according to the given of the problem and according to the required. Okay? Let's solve these two examples together. Okay? In this example, here, we have that BD, its length is x centimeter, and CD equals 8, and DA equals 18. So here, this is a very simple question. Just need you to know the rule of Euclidean theorem. Okay? Here, we all know that BD, we can find BD square by multiplying AD times DC. Multiplying AD multiplying by DC. Okay? BD square, its length will be x squared equals AD, which is equals to 18, multiplied by CD, which is equals to 8. Okay? Here you can use your calculator to find. Here you are going to use your calculator to find the result of 8 multiplied by 18. Okay? So bring your calculator to find 8 multiplied by 18, and this is equals to 144. So x squared will be equals to 144. By taking square root, x will be equals to 12 centimeter. Okay? Again, the second example, example 2. Here he wants to find the value of x. Okay? And we know the value of the altitude or the height of the right angle triangle. So we can write that again, EC. Here we can write EC squared equals, here EC equals BE multiplied by BD. Okay? Concentrate please and focus in this part. EC square will be equals to 6 squared. Here BE equals 4 centimeter. But we don't know the length of BD. But BD equals BE plus ED. So it will be equals to 2x plus 1 plus 4. If we add them together, it will be 2x plus 5. So we write 6 power 2 equals 4 multiplied by 2x plus 5. Okay? 6 power 2, it will be equals to 36. 4 multiplied by 2x, it will be equals to 8x. 4 plus 4 multiplied by 5, it will be equals to 20. 20 will go to the other side. So 8x will be 36 minus 20, it will be 16 divided by 8. So x will be equals 2. So in the first example, x equals 8, and in the second one, x equal 12. Okay? Thank you so much. Until we meet again next time, goodbye and good luck.